Hi everyone, welcome to the Java E8, the Next Frontier project. And today I have a very special guest here, Mr. Gunnar Morling. He is the spec lead of the Bean Validation 2.0. And Gunnar, thank you very much for accepting our invitation and be very welcome here today.
Mhm. All right, thank you so much for having me, Elder. It's a real pleasure for me to be here. Yeah, I think it's just my second Hangout on Air, so I'm really excited about to do this. And yeah, I look forward to this session. If you have any questions, post them on YouTube, and Elder will then monitor the questions and relay them to me if anything comes up.
Sure, absolutely.
Yeah, all right, so
I will
let's...
keep it.
Right. So then let's get started. So what can you expect? So I will give an overview about what bean validation is, what can you do with it, and I will do that mostly in the IDE. So I've prepared a little demonstration, and we will show some of the bean validation features right in Eclipse. And after that, I will go over the new features which are in bean validation 2.0, so which is the new revision we have been working on the last year, and I will tell you what is added there and what can you expect then as part of the upcoming Java E8 release. And as said, if there are any questions, feel free to ask them during the session or at the end, as you like. Before I start, let me quickly introduce myself. So my name is Gunnar, and I work as a software engineer at Red Hat, where I'm a member of the Hibernate team. And as you probably know, Hibernate is not just the classic Hibernate ORM, the object relational mapping tool, but actually it's an entire family of data-related open source projects. And bean validation and the reference implementation is one of those data-related projects which I'm working on. Another project I'm more focused now that bean validation is done is Debezium, which is a tool for change data capture. So essentially this means you can capture the events from a database, let's say Postgres or Mongo, and then representing all the changes from the database into a Kafka queue, which enables all sorts of interesting use cases, such as updating a full text search index or replicating data just to another database or whatever you like. And so that's Debezium. And yeah, in case you are wondering why I'm doing this talk, so I'm working as the spec lead of bean validation, and a couple of other projects I'm doing on the side. So they are not Red Hat projects, but more side efforts are MapStruct, which is a code generator for bean-to-bean mapping tools, for bean-to-bean mapping code, sorry, and Modetect, which is a project which helps you to deal with Java 9 modules and the module descriptors. So now let's make it start. Something weird happened. Just let me see. The font size went a bit crazy. 1 second. What's that? Hold on. I'm not sure what went wrong here, but now it's looking better. All right. Okay, so with that, let's get started really. And what is bean validation about? So the idea is to provide you with an API which lets you put constraints to your model. So constraints could be any kinds of checks or preconditions which you would like to have satisfied. For instance, you could say, okay, this property, it should be not null, or this string property, it should satisfy a specific regular expression, or this other property, which is a numeric property, it should be within a given range. So you can have all those kinds of checks, which we call constraints, and they are expressed using Java annotations. So you put those annotations to your model, and then the idea is that you validate those constraints, or actually they will be validated for you automatically whenever it makes sense in the object lifecycle. So bean validation is integrated with a lot of other specs and technologies, for instance, JPA, the Java Persistence API, or JAX-RS, which is the REST web service API in Java E. And all those specs will trigger validation of the objects whenever it makes sense. So for instance, when you are about to send data to the database and persist them using JPA, then JPA will automatically trigger the validation for you. The same, for instance, for JSF or Spring MVC. If you have a model which is bound to a user interface, and then you, for instance, submit the dialog in JSF, the validation will automatically kick in and validate all the properties of your beans. And so the tagline is constrain once, validate everywhere. So this means you put the constraints once to your model, and then they will be validated automatically for you. It is extensible, which we will see in a bit. So you can add your own constraints by defining custom constraint annotations. And actually, it's not even limited to just validating the properties of beans, but you also can, as of bean validation 1.1, validate any method parameters and method return values. So this works by putting constraints to the parameters of methods, or by putting constraint annotations to methods themselves. And then if your code runs in an some kind of managed environment, such as a CDI container or a Spring container, then the parameter and return value constraints will be invoked and will be validated automatically when the methods are executed. So that's the very quick overview. And now let me switch to Eclipse. And I've prepared a little demo project for you. And this is a regular business application. So it deals with hikes and the management of hikes. And so if we have business entities here, like this hike class, which is a JPA entity, and I have a data access layer. So for instance, I have this hike repository, which deals then with using the entity manager, stores the data into the database. And I have this REST layer, which is the which provides an endpoint for REST calls. So we could, for instance, save hikes or save orders of a hike, and so on and so on. And let me show you this in the browser. So this is the application. It's called Hiker, and so it's just your regular CRUD application. I have here this list of hikes. I can create a new hike and say from here, or let me say from Hamburg, which is the place where I live, to Sao Paulo, for instance. So it's saved, and I will now add a bit of validation to this application, and we will see how easy this actually is. And one interesting thing about this application is, so this is using JPA to save the data, but it is not using a relational database as the backend, but instead it is using MongoDB. And I'm doing this, or this gets possible by using another project from Hibernate, from the Hibernate umbrella, which is called Hibernate OGM. And this is a project which lets you use JPA and Hibernate to talk to NoSQL stores. So if I go to my persistence XML here, what I see here is, as a provider, I have Hibernate OGM persistence, and this essentially tells the Hibernate engine, okay, use this NoSQL engine for me. And then I have some specific properties here, which are, for instance, the endpoint or the provider, MongoDB in this case. And this makes it very easy for me to talk to MongoDB. So if you're interested in this kind of approach, just look for Hibernate OGM. Okay, so that's the application. And now let me add a bit of a validation to it. And I have prepared this test class here. And the first thing I will create now is a validator. And I have this validation factory class for me, and get a validator factory from it. I could customize this a bit, but I'm not too interested in the customization. I just take the default. So let me assign it. And as I said, usually you would not make use of this API and validate entities or objects yourself manually, but let me do this for the time being to see what can be done. And I have this customer object. Customer, where is it? And this is a very simple class, and I even have just a public fields here, so not even getters and setters. And I can now add this constraint add email here. And add email actually is a new constraint in Bean Validation 2.0. And yeah, now let me validate this customer object and see what I get as a result if it happens to be invalid. So I go back to the test, have this customer, and I set its email address to something which is not an email address. So there's no add character in it, so that makes it not a valid email address for our purposes. And now I can use the validator call, validate, pass the customer. And what I get back is a set of constraint violations. And this set would be empty in case the object would be valid, so no constraint violation would then be part of the set. But now I'm expecting actually a constraint error, and I will find out about it by iterating over the set. So I can iterate over the constraint violations, and just for the sake of the example, I'm printing out some of the details which I can get. So let's see, we can, for instance, the message. So each constraint violation has a message. Let me print that one. Let me print what we call the property path, which essentially is the name of the property, as we will see in a bit. Get property path. And I also can get information about the constraint which has been violated. In this case, I would use this constraint descriptor I'm having here. And for instance, now I can navigate to the annotation and from there to the annotation type. So this should be enough for now. Let me run this for you. Small JUnit test. Test bar is green because I don't have any assertions, but on the output now I see what I would expect. So it's one constraint violation. The messages must be aware from email address, which it isn't. The property path just is email, and the annotation is that constraint type. So that was easy. What I now can do is I can validate entire object graphs, and I have here this order object, which, let's say, represents the order of one hike in our application. And now whenever an order object gets validated, I also would like to validate the customer, which is associated to the order. And for that, I just need to put this @valid annotation here. And I also will just put another constraint to the order itself. Let's say the number should not be null. And let me run it again. And now I'm still getting the same exception because I'm still validating this customer. So let me change it and say new order. And I set the customer to the customer which we just have created above. And now I would expect 2 violations. Yeah, of course I should validate this object. Sorry about that. Now I get a set of constraint violations parameterized with order. And indeed, now I'm getting those 2 exceptions. So there's now these 2 errors, constraint violations. So there's now this must not be null constraint violation on the number property. And now we also see why it is called property path, because now actually it is the path from the order customer reference to the email. So that's why we see customer.email as the property path here for the email constraint. So that's that. And as I said, it's also extensible. So I can easily add my own constraint annotations. And let's say I'm going back to the order class again. And here I have 2 properties, order date and shipment date. And now I would like to express, OK, the shipment date, it always must be after the order date. So it doesn't make sense if the shipment date is before the order date. I would like to validate that. And I do this, or for doing this, I will create what is called a class level constraint. And a class level constraint, sorry, wait, order. This one does not sit on one of the properties, but it sits actually on the class itself. So let me create this annotation type, valid order. And now I need to add some metadata to it. For instance, I must mark this with the add constraint meta annotation, which marks this as a constraint annotation type. But to save some time, I will speed this up a little bit and run this small template. So I say now, OK, this is a constraint. I say, what are the supported targets? Where can I use this constraint? So for a class level constraint, typically I just would put type in here probably. Then retention, this means how can this annotation type be accessed? So I want this annotation to be accessible at runtime using a reflection. So I need to put the retention policy runtime in here. And I also mark this as a repeatable constraint, which will I explain in a bit. And each constraint annotation has a couple of properties. So for instance, there's this message property, which takes the error message if we want to override it. There's this groups property, which lets us assign this constraint to validation groups, which lets us validate different subsets of constraints. And then there's a payload property, which essentially lets me put some arbitrary metadata to a constraint. So I need all those 3 properties for each constraint. And then I said it's repeatable, and a repeatable annotation, or for a repeatable annotation, I need to create this other annotation, which I here call just add list. And then from the repeatable meta annotation, I reference this list type. So this will then be used by the Java compiler to make this annotation repeatable. And finally, I need a constraint validator implementation. And first organize the imports. This class, I just have created it as an inner class here. It could be located somewhere else, of course. But this implements the constraint validator interface, and then it is parameterized with the type of the constraint, valid order in this case, and the type which is the target of this specific validator. So this constraint validator applies the valid order constraint to the order objects. And I just implement this isValid method here, and essentially all I do is I return true if the shipment date is after the order date, and I ignore any null properties, which is a common best practice for writing constraints. So that's all I need to do for declaring this constraint. I have assigned it to the order class, or I have put it to the order class. And now let me go back to my test and see whether I can create a violation of this constraint. And for that, I just set the shipment date to some date, local date. Let's say this year. And I have the order date. And I set this to something after the shipment date. So I would expect now that this constraint is violated as well. So if I run the test again, I indeed get now 3 constraint violations. And this third one is the interesting one. So it has the message we expect. It's an invalid order shipment date because it is not after the order date. The property path is empty because well, there is no property. It's just this class level constraint, and the annotation is the valid order annotation. All right, so that's how I create a custom constraint. And then, as I said before, usually I won't call the validation engine myself by getting a validator and then pass the object to validate, but instead this will happen automatically for me. And I will show how this happens using our application again. And I have, for this, I have started a Wildfly application server here. And now I'm just using curl, or sorry, the HTTP command line client to invoke some of the REST endpoints of this application. And let me see. I have this JSON request prepared here. So, and this is, let's say, it's a document which presents the order creation. It just has the customer data here, and it's not a valid email address. So we would expect a constraint violation. So let me post this to this endpoint. Oh, sorry. Yeah, I don't get a constraint violation because what I have forgotten is I should, of course, deploy this application with the changes I just have done. So let me deploy it for you. This takes a few seconds using the Wildfly plugin for Maven. So now the application is updated, and hopefully now if I submit this request again, I'm getting an error, which is interesting. So I get the constraint violation, which I have expected. So it says here it must be a well-formed email address. So that's what I expect. But then if I look at the status code of this REST request, actually I see it's an internal server error, HTTP code 500, which is logical if you think about it, when we see where the validation has been triggered. And it has actually been triggered just by the JPA, by the persistence layer, so at the very last point of this request processing. So JPA kicked in and made sure that we don't write any invalid data to the database. But actually, we would like to have the validation happen much earlier than that, already when the data gets into the system, so right when the REST request is processed. And for that, I go to my order resource class. So this is the endpoint which I just have invoked. And I put now this valid annotation here, which then uses the method validation feature, which I mentioned earlier. So this means now if this method gets invoked when I call the REST endpoint, this order object will be validated. So for that, I'm deploying the application again with just this little change. And now, hopefully, if I execute this request again, I should get a slightly different error message. Let me do it. And indeed, I get a much nicer, more nicely formatted message. So actually, it says it's about a constraint on a parameter. So it must be a well-formed email address. I get the property path here. And if I look here now at the status code, I see it's actually HTTP 500. So something was wrong with the request, which in turn, which actually is what I would expect here, because the provided data was invalid. So yeah, as you see, it's quite easy to trigger invalidation in the course of, for instance, this REST application. But actually, it's not even limited to the server side. So this all happens so far on the server side. But what I also could do is I could use bean validation and its metadata to perform validation on the client side. And for that, let me go back to my application. And I have here this dialog for creating a new hike. And as you see, as I type here, some validation kicks in. So it must be between 3 and 20 characters long. And actually, this validation happens right on the client side. So this is an Angular application. And whenever I type the validation on the client side, within the browser kicks in. And of course, I don't want to repeat all the constraint metadata on the client side as well, because I already have given it on the server side. And for this project Welder comes in very handy. And what it does actually is it provides a servlet with all the constraint metadata. And then there's a client-side part of this project Welder, which then takes this metadata from the server and applies it to generate validation errors on the Angular JS application. So let me call this, sorry, that was this resource for you. So this is just a JSON representation of the constraints which we have defined on the server side. And then, as said, the client part or the client-side part of the application can come along and enforce those constraints already on the client side before we even send a request to the server. All right, so that's it about in terms of what bean validation in general can do for you. So let me go back to the slides. And now let me talk a bit what actually is new in bean validation 2.0. So all the stuff which you have seen so far, that's essentially already possible in bean validation 1. But now let's have a look what's new in bean validation 2.0. And really the idea of it was to support and take advantage of Java 8. So that's the tagline here, support and take advantage of Java 8. And this falls in two categories, really. So for once, we want to benefit from the new language features in Java 8. So for instance, repeatable annotations or type annotations, which, as we will see, are very useful for bean validation. And so we wanted to take advantage of those. And then, of course, we also wanted to provide support for the new APIs in Java 8. So for instance, there's this new date and time API defined by JSR 3.10, and bean validation should support these API extensions. And now you may wonder, why is it bean validation 2.0? So why is it a new major version? And the reason is we looked into it and we found out, okay, if we want to support Java 8, we cannot really do this in a backwards compatible fashion. So it really means if you want to support Java 8, it means applications using then this API also will have to move to Java 8, and this is the minimum Java version. And so we said, okay, this should be reflected in a new major version, this requirement of Java 8. And I want to go through some of the new features, and I'm doing this in a use case-oriented fashion. So I will discuss some typical use cases, and then we will see how bean validation 2 will help you with those. And the first use case is you would like to make sure that different users with different roles in your application, that they have different passwords. So let's say you have this password property here as a character array. And now you would say, okay, if my user is a regular user, his or their password should be, let's say, 8 characters long. Whereas if the user is in the administrator group, I would like to make sure that their password is a bit longer. So let's say 12 characters. And the way I do this in bean validation typically is I specify this constraint at size multiple times here, and then I use different parameterizations. So different values for the min property. And I assign the constraints to different groups. So these validation groups allow me to validate different subsets of those constraints. And if I wanted to use this at size annotation multiple times, I so far had to do so using this @list annotation explicitly. So this was the way to do it. And now, thanks to Java 8, I just can omit this list annotation. So I just can specify the constraint multiple times. And the interesting thing is that the compiler will actually generate bytecode which looks exactly the same as in the previous version. So using this repeatable annotation, which we have seen, under the hood, still this @list annotation is present in the bytecode. But then for me as a user of this constraint, it's getting a bit simpler, which I would say is very nice. And then the next use case is I would like to make sure that my collection of, let's say, strings does not contain any empty elements. So I have this list of names, and I want to make sure no empty string is contained in this list. Well, and there's this @notEmpty constraint, which has been a part of the Hibernate validator, which is the reference implementation, and this @notEmpty constraint now is part of the spec, actually. But, well, I can use it, or I could use it on the property itself, but this actually would just mean that this list itself should not be empty. So this would not make any expression on the contents of the list. And then in the times of bean validation 1.x, we always wondered, okay, so is there a way we could somehow say, let's apply this constraint to the elements? And so one could think about this onElements annotation, and then it could take other constraint annotation, and this would then express, okay, please apply it not to the names list itself, but just to the elements, actually. It turns out this is not really possible to implement in a generic way, because you cannot define an onElements annotation like this, which would take any kind of constraint. Instead, you always could only apply it to a specific annotation type. And this means we would need an onElements annotation for each and every constraint, which did not seem desirable. So we did not really find a good way in the old times, which is why we never went for it. But now, thankfully, to Java 8 and the advent of type annotations, it gets very nicely doable, because now what we can do is we can put constraints to the type arguments of those generic types. So I now can put the @notEmpty annotation to the type argument string, and now it suddenly gets very clear that this constraint is meant to be applied to the strings within the list and not the list itself. So this is possible now as of Java 8. I can put annotations in many more places, and bean validation takes very much advantage of that. I could put multiple constraints there, so I could say it should be not empty, or each name should not be empty, and each name should satisfy this specific regular expression. And of course, I can combine the @notEmpty annotation on the list itself and then on the elements. So this means this names list, it should not be empty. There should be at least one name in there, and each name should be a non-empty string. And the type annotations, so they're as of Java 8, they have been defined by the JSR 3.8, and the key to defining an annotation which can be used in that way is to add this new target type use. So for each annotation, I need to say at which elements in a Java class can this annotation be used. And if I add this type use element type, then it can be used on type arguments. The type annotations are also useful for this feature of cascaded validation. So we already saw it for the reference from the order class to the customer class. But I also can use this @valid annotation for collections of elements. So I have here this addresses list, and I want to make sure each address in this list is valid. All the constraints on each address are satisfied. So I put this @valid annotation there. Now, what is doable in bean validation 2, I can also put this to the type argument. So the semantics are pretty much the same. It's just a matter of style. But yeah, I would say it's a bit more expressive. But the advantages get a bit more apparent if we talk about maps, because bean validation always had support for maps, but only for the values which are stored in the map. So I only so far could make sure that the map values are valid. Whereas now in bean validation 2, I can put this @valid annotation to the key type argument, which means, okay, now this comment object, which is used as a key in this map, all the comments should be validated when this map property gets validated. And again, I can combine it, or I can actually navigate into nested collections. So here I'm saying, okay, when this addresses by type map gets validated, then please validate all the address type keys, and then also validate all the addresses of all the lists, which are the map values here. And I could nest this even more. Probably I would at some point create a more meaningful domain-specific type, but I can use this to validate this kind of nested collections. It doesn't stop there. So Java 8 defines this optional return or this optional type, which you would now use in your programs if a method either could return a value or not. So whereas before you would have to return null or not null, and you would have to make this apparent in the documentation, now such a method would return an optional. And again, I can use constraints on the type argument of the optional to say, okay, this string, if it is returned by the optional, if it is present, then it should be a valid email address. There are specifics, types related to optional. There's optional int, optional long, optional double. All those types are supported. And also the property types of JavaFX are supported. And for that, let me go back to Eclipse. And I have prepared, or actually a colleague from the expert group, Hendrik Ebbers, he has prepared a little demo using JavaFX. So let me show it for you. So there's this model, and in JavaFX, what you have is you have these property types typically. So instead of integers in your model, or you have this string property instead of a string, and you use those property types in the model, which comes, for instance, with the advantage that they can be observed. And we also support now the constraints on those properties. So here the admin constraint is applied to the integer, or this add size constraint is applied to the elements of this list property. Let me start this little demo to show you how it looks. So this is just a very simple dialog. And now we see here the constraint violation messages. It's a bit small, but I hope you can see it. So this says it must not be empty, or this says it must be greater than 50. And now if I change the values, the validation error goes away. So validation happens automatically whenever this bound value is changed. And yeah, so this is makes it quite easy to get validation also into your JavaFX applications. It's the same for these lists here. I can add those tags, and then the constraints will be validated automatically. So that's JavaFX. Let me get back. And actually, it doesn't stop there, because, well, you could have your custom collection types. So for instance, if you think about Google Guava, which is a very useful library, I guess many of you are using it, then Guava comes with many custom collection types. So for instance, you have this table type, which you could imagine like a spreadsheet, or you have a graph, or like a graph type, or like a multi-map type, and many more specific collection types. And of course, we also would like to use constraints on those custom collection types. Or you could even think beyond Java as a language. You could think of other JVM languages. So for instance, Ceylon or Scala, which come with their own collection libraries. So Ceylon, it does not use the Java collection library, but it has its own specific collection types. And well, it would be nice if you could use those constraints for these collection types as well. And of course, beam validation as a spec, it cannot know about all those custom collection types. So we cannot add support or we cannot build it into the spec. But what we have done instead is we have defined an extension mechanism, an SPI, and service provider interface, which makes it quite easy for you to plug in custom, what we call value extractors, which then support those custom collection types. And as an example, I have here this table. So this is from Guava, revenue per year and category. So you could imagine it as a two-dimensional spreadsheet. So we have here a revenue value, which is stored per year and per category. So it's like a two-dimensional spreadsheet. And now let's see how we can put constraints to this. So we would like to say, okay, the revenue for each year and for each category, it should be a positive number. So positive also is another new constraint in beam validation too. And we would like now have support for putting constraints to the values of a table. So let me go back to Eclipse. And I've prepared another test for this. So I've already instantiated the validator, and I have here this revenue class, which has this property, which we just have seen on these slides. So it has this revenue per year and category with the positive constraint, and there's one invalid value which we have stored in here, so it's a negative value. And let me run this, and we see what happens. And I'm actually getting an exception, which I now really expect. And the error message, it says, let me read it for you. It says, no value extractor found for type parameter v of the type table. So the Bean validation engine, it has detected, okay, there's this constraint here, but I don't know how to retrieve values for this type argument, really. So I need some help with that. And for that, what I need to do now is I need to create a table. Oh, I need to create a value extractor which deals with table values. So I create a new class, table cell extractor, and it implements this SPI interface value extractor, which is parameterized with the type to extract from. So this would be table. And this one just defines a single method, extract values. And the way it works is it's passed the container object to extract the values from. So this is a table. And then it receives another object, which is essentially a callback to this value receiver. And the implementation I need to do now is I must call the methods on this receiver object for each value which is stored in the table. So let me iterate through the values of the table. And there is this method cell set. So this iterates over these cells from the table. And then I have this receiver object, and it has different methods like indexed value, iterable value, and so on. I'm here using now keyed value, which means, well, this cell, it has a key which comprises of the column and the row, and I would like to be this part of the resulting constraint violation and its property path. So I call keyed value. I need to assign a node name. Let me say table cell. We will see in a bit where this is used. I will deal with the key in a bit. And as the value, I say cell get value. And now I need this key object. And I need to create a custom class for this because, well, I don't have any yet. So let me call it cell key. And this essentially should just represent a row and a column key from the table. So it's a plain little DTO. So I've prepared this little template for me. And essentially, it just takes the row key, the column key, adds a toString method, adds equals and hash code, and that's about it. So it's just the combination of a row and a column key. Fix the imports, and now I can use this. So I'm going back to the extractor, and I say cell key for cell, and I'm passing the cell, which I'm getting from the iterator. So that's all I need to do. There's one more thing I need to say, or I need to specify which of the three type arguments from table is the one which this extractor deals with. And for that, I'm using this extracted value annotation. So using the type annotations, I actually can now also put annotations to this place, which may look a bit unfamiliar, but it's doable in Java 8. And now this means this specific extractor, it is there for the third type parameter of the table type. So it's it in terms of the implementation. And now I need to make it known to the validation engine. And I'm using the service loader mechanism for this. So I just take the qualified name. And the way this works is I have this file here, which has the fully qualified name of this provider contract. So it's JavaX validation, value extraction, value extractor. And I put the names of one or more implementations into this file. So I'm just having this single extractor. So that's the contents for this services file. And now if I run the test again, it should pick up this file. It should pick up the implementation and make use of it to extract the values from the table. So let me run the test again. And indeed, it's green now. And if I look what I've done, so I'm printing out the property path here. And this is what I would expect. So this is on the revenue per year and category property. It's using this cell key which we have created in the brackets, and it's using as another node in this property path this node name which we have emitted by or within the array extractor. And this is how I could add support for any other collection or container type I could think of. And by the way, by using the service loader mechanism, it gets very nicely doable for others to provide their extractors and make them automatically picked up from the class path. So let's say the Guava developers would like to add support for beam validation for their connection types. They just would add those implementations, would add the services file to the Guava library, and then beam validation would automatically pick it up. All right, so that's custom containers.
Hey Gunnar.
Yeah, sure.
Can I? We have two questions here from the YouTube. Can I ask you?
Absolutely, sure.
One question is from Manik. He's asking: is there any order for executions for validations from property type to type use? There is any other defined for the executions?
So the question is there any defined order of execution? That's the question, right?
Yeah, for validations from property.
Right.
Type to type use.
Right, and the answer is no, there's no defined order. So if your property gets validated, then all the traditional property constraints and all the constraints on the type arguments of that property, they will all be validated essentially in one go, and there's no way or no guarantee on the order by default. So if you need an order, if you wanted to say, I first want to validate this traditional property constraint, and let's say then only the container constraints, you would have to use what is called group sequences, and which then allow you to assign the constraints to different groups, and you can say, or you can then specify the order of groups which should be validated. So this would be the way to do it.
Okay, awesome. And just one more question from Andrea. He's asking if there's a performance impact if we have tons of constraints or a few constraints on tons of data. If we should expect some performance impact.
Well, should you expect a performance impact? So, I mean, it depends a bit on your data. So let's say you have, in this list, you have 100,000 elements, and you have put this container element constraint. Well, sure, then we need to iterate over all the 100,000 elements and apply the constraints. I guess you would notice this, but usually I would say in your traditional application and with reasonable data sizes, you would not expect, or you would not notice any difference. And that said, we spent quite a bit of efforts on performance optimization for the high-bandwidth dual data reference implementation as part of the newest release. So it actually should be faster than the old version high-bandwidth dual data 5 in many cases.
Okay, thank you. That's all for now.
Yeah. All right.
Thank you very much.
So that's it for container constraints. Then the next use case, which is supported by Java or by Bean Validation 2, is the validation of dates. And Bean Validation always had those two constraints, at past and at future, and they were supported just for calendar and date, which were the traditional date types. And now Java 8 has this new date and time API with lots of new types, such as local date time, zoned date time, and many more. And well, the at past and the future constraints are usable for all those new date types now. So you could say, okay, this local date delivery date, it should be in the future. There's a new companion to add future and also to add past, which is add future or present. And this means also consider the current time or the current moment as valid. And what the current moment means, this depends on the type which this is about. So for example, here, this is a local date. So this would be valid if the local date either is in the future or the entire current day, really. Or if it was on a year, so there's this new type year, future or present, it would be valid if it either is a future year or the entire current year. So this is how this works. And there are some other improvements related to the time support. So before bean validation 2, what now is you need to know the current time to say, okay, this date is in the past or in the future. This always was the time of the JVM, the default time, and using the default time zone from the JVM, and not sometimes this is not what you want. So let's say you have a multi-user application with users from different countries around the world. You probably would like to use their current time and their current time zone to say what is now. Or if you think about testing, well, what you would have done in the past is you would have set the state in your test to some point very far in the future, and your test would be fine. And then over the years, time progresses, and suddenly your test fails. And this is because now the state which you had set to the future at some point, now it's actually in the past. So this was all a bit tricky to get right. And this gets much easier now using this clock provider contract. And the clock provider is an extension mechanism which makes it customizable for you to define what is now for the validation of those state constraints. And here in this example, I'm just using a fixed clock provider. So this returns always the same date and time, which would be useful in a test. But if you think about this multi-user application, where you would have a clock provider, which then, for instance, would return the time and time zone from the, let's say, context of the logged in user. Yeah, some other goodies. So very often we have this case where a constraint validator implementation doesn't actually need to deal with any properties from the constraint. So if you have this at not null constraint, so there's not a property on not null, it's just a constraint which is there or which isn't there. So traditionally, you still had to implement this initialize method. Then you would just not do anything. Only if you had a constraint, let's say at min, which actually has a property which you then would store in this validator instance, then you actually would have implemented initialize, but otherwise it would wasn't really needed. And this gets a bit nicer now using Java 8 default methods. So the constraint validator contract has been changed in a way that the initialize method is now a default method which doesn't do anything, which simplifies this implementation of this kind of validators which don't need to access any kind of constraint attribute. There's a couple of new constraints which we mostly have already seen. So there's not empty and not blank, which deal with strings. There's at email, which has been part of the reference implementation before and which has been promoted to the spec. Just to keep in mind here is it is very difficult to say what is a valid email address, and different people have different ideas about it. So we intentionally said, okay, we don't specify this, and we just specify the annotation, but then actually it's implementation specific what the exact rules for an email or for the validation of an email are. So this is something to keep in mind. And there also is a way you can narrow it down using regular expressions if you wanted to. Then there are these constraints, positive, positive or zero, negative, negative or zero, which deal with numeric values. And we have already seen those past or present and future or present. And you may wonder, okay, how did you arrive at those constraints? So how did we decide that it should be these here, which we should add? And the answer is we involved the community. So we tried to bring the community on board as often as possible. And we actually did a survey using Google Forms, I think. And so we asked, okay, what should be the constraints to add? And what we also did is we ran an analysis of essentially all Java code which exists on GitHub, and we searched for all the constraints which are used there, but which have not been defined by the spec. So this analysis told us about usages of the custom constraints from Hibernate Validator or any other custom constraints people would have been used. And so that's how we arrived on this set of constraints. And then also for the specific details of, let's say, the positive constraint or the positive or zero constraints, we again asked the community in a survey, should this strict or this or zero behavior, should it just be a property on positive, or should it be a separate annotation? And actually most people favored a separate annotation, so that's it. In terms of the status, so we are, I guess you have seen it on Twitter, we just passed the final approval ballot last week, and we also did the final release. So this means you can get the 0.0 final release from Maven Central already. It is done. And I'm very happy to say that the voting by the Java executive committee, it was anonymous. So all the 25 members, they voted in favor of us, which yeah, is really good. And yeah, so speaking about the life cycle of this JSR, yeah, we are at the very end now. So the expert group essentially will disband. The work is done. And also the reference implementation is done. So there's Hibernate Validator 6, which we also released last week. And you actually can try this out in Glassfish, which is the reference implementation of Java EE8. So Glassfish pulls in all the latest builds we are doing of the API, which is done now, and also the reference implementation. I think they are still at the latest candidate release, which was the one we sent to the final approval build, but I would expect the next drop of Glassfish or one after that will contain the final release. And if you are running your applications on Wildfly, you also can try out Bean Validation 2.0 very easily, because we provide patch files for Wildfly. And there's this patching infrastructure, which makes it very easy to upgrade the Hibernate Validator implementation, which comes with Wildfly, to upgrade it to Hibernate Validator 6, and then use the Bean Validation 2 API. And everything will be part of Java EE8, which is planned to be released in the summer. So the final approval ballot has begun this week, and also there's one, or I think two more specs where the final approval ballot is still running, the security and the servlet spec, I think. And so I would expect it's not much longer until Java EE8 is finalized and we can see the Glassfish reference implementation also being finalized. Just very quickly, so Bean Validation 2.0, it is done. Some ideas we could not add to 2.0 at some point. We might do a 2.1. There's no decision on this yet, but we might do it. One idea being a constraint API. So this would let you define constraints in a more dynamic fashion. So currently what we have is annotations and XML, which both is rather static. But Hibernate Validator already provides an API which allows you to define constraints dynamically using this Fluent API. So you navigate to a type, and then you navigate to a property, you put those constraints, and so on and so on. This could be something interesting to be added to Bean Validation 2.1. And it also could be used with Lambda expressions as introduced by Java 8. So we could say, okay, I have this constraint type file exists, and when it is applied to a file object, I want to execute this Lambda expression. So I don't even need to define a constraint validator here. Or we could even go one step further and just omit this constraint annotation type altogether and just specify Lambda expressions, which then should be validated or which should be applied to certain properties. This all will be something which we will experiment with a bit in the future, and then at some point it might be added. Yeah, finally, some resources. So this spec, or let me say beanvalidation.org, that's the hub with everything around bean validation. You will find the spec there. All the code is on the github.com bean validation repo. So there's the API, there's the specification, which is written in ASCII doc, by the way, so it's quite easily editable and readable also in the source. There's the TCK, the test kit, and even the website, beanvalidation.org. So everything is on GitHub. Everything is open source. So if you would like to contribute or you find a fix, it's quite easy to do. I mean, right now the API is just, or bean validation 2.0 is just done, so we won't do any changes in the near term, but still it's open for contributions eventually. And also the reference implementation, this is probably the part which is a bit more active in the very near future. It's on GitHub under the Hibernate organization, and the plan really is to experiment with features which we could not add to 2.0 due to time restrictions or whatever reasons. So we will add those to the reference implementation, experiment a bit with them, get some experiences, and then eventually promote them to the spec in a future revision. And help with that would be very welcomed. And with that, I am done. If there are any questions, I would be happy to answer them. Otherwise, if you like to learn about any news, follow me on Twitter. And yeah, with that, thank you so much.
Thank you, Gunnar. There are no more questions. And the guys who asked those questions, I would like to thank you for the answers.
All right, cool.
And thank you very much. Thank you again. It's a pleasure to have you here. I hope you have a great day.
Thank you so much, Framiri. And yeah, if there are any questions afterwards, just let me know and I will be happy to help. Thank you so much.
Sure, we will do. So guys, thank you very much again for having us and have a good day. Bye-bye.